Right, thank you, Andrew. So today, good morning, I'm going to be talking about my master's dissertation, giving you a brief walk through my research on combined use of dental microwear texture analysis and calculus microdebris analysis on early medieval remains from Llandough. It's worth before I start pointing out that my definition of early medieval is much the same as Katie's. Katie was actually my supervisor for this project, so I'm following the same sort of definition that she did, where it's the first half of the period up until about the 10th or 11th centuries. There's a lot to get through here, including some pretty niche stuff, so let's get started. So we'll get into the specifics of these analyses later, but this project functioned as a pilot study for the combined use of two methods that are already established. First is CMA, which stands for Calculus Microdebris Analysis. This is a method where we look at the tiny particles trapped within calculus, which is mineralized plaque. It's also called tartar in a dental context. The second is dental microwear texture analysis. This is where we analyze the microscopic wear patterns left behind on a tooth from things chewed and eaten during a person's life. These are both established methods. CMA has been often used with industrial populations, particularly in recent years. The MTA has been widely used in zooarchaeology in the UK and osteoarchaeology in the States as well, especially with Indigenous American communities, but it's not widely been used in British osteoarchaeology yet. And as far as I'm aware, this is the first Welsh use of either of these methods, so the first use on Welsh remains. As I previously stated, the work was completed as part of my master's in archaeological science at Cardiff University between June and October 2023, and the lab work happened um, at that university as well. So, a quick overview of the site. The remains studied in this project were excavated from St. Doctor's Monastery, which was founded around 500 CE. There are over 1,000 burials at the site, so it's fairly large. Carbon dating suggests that the burials were um, begun around 370 to 640 and ended 782 to 1024. Um, so they spanned up to about 650 years, fairly large date range. The relevant excavations for this work were in 1994, but there were prior excavations in 1963 and 1979. The site's very rich with archaeology across periods, including Roman. Um, so, as we can see here, this is the location of the site within South Wales. It's located in Llandough, which is western Cardiff. It's just west of the River Ely. Previous excavations, like I said before, happened in 1963 and 79. The 1963 excavation was just next to this Roman villa and uncovered a corner of it. So then there was a further excavation in 1979. And then in 1994, the early medieval remains were turned up on the other side of the church. But for today, we'll just be focusing on the 1994 excavation. It did also turn up some Roman skeletal remains, but we're only going to be talking about the early medieval ones today. So this research aimed to follow two research questions. Number one, can dental microwear and calculus analysis act as a non-destructive alternative for dietary reconstruction? So most forms of dietary reconstruction are destructive to at least some degree or require the modification, permanent modification of human remains. For example, stable isotope analysis, probably the most popular analysis method for dietary reconstruction. It requires destruction of either bone or dental enamel. The amount of destruction has reduced with technological advances. It used to be much higher, but at the moment, removal of human tissue is still necessary. And then number two, what are the links between microbiomes and diet in medieval Wales? So in this context, microbiomes refers to an individual's oral microbiology rather than a geographical microbiome. So now we've gone through those. The lab work was carried out by both Katie Furse and myself, the bioarchaeology lab, Cardiff University. We also had a separate clean lab, which was created for the CMA. We then carried out some analysis with additional guidance from our additional personnel. Um, Adele Bricking of Amgueddfa Cymru was our point of contact at the museum, and she was incredibly helpful throughout the entire process. We also had two specialist advisors. Dr. Chris Schmidt from the University of Indianapolis is an expert in DMTA, and he held an advisory role. Similarly, Dr. Anita Radini from University College Dublin advised on dental calculus analysis and findings. So both provided us with expert advice and reviewed our findings to provide further insight. So moving on, let's discuss the methodology. So both forms of analysis, we used the Keyence VHX 6000 series 4K digital microscope. And it's a very shiny new high-tech bit of kit at the uni, and I was really excited to use it. I've attached some photos of the process of creating the casts for the DMTA, which we'll go into further detail in a minute about this process. I don't have any photos of the CMA process because it's very sensitive. We carried it out in a clean lab, so I avoided basically anything that wasn't completely necessary around them. So I'm not going to go through the methodology step by step because, as you can see, they're fairly long, but I will point out the most important parts of the process. So essentially, to carry out calculus microdebris analysis, we remove the dental calculus from the teeth just using a metal tool, grind it down with a tiny pestle and mortar, and dissolve it into a liquid suspension. We then, after a few steps of processing, pipette these solutions out onto microscope slides, seal them, and then view them under a microscope at quite high magnification of 500 times. And the same with DMTA. I'm not going to go through it completely, but I'll give you the gist of it. We take molds of the teeth. It's using a silicone impression material. So if anyone's ever had to have a retainer or mouth guard or something like that fitted, it's the same stuff that they use for that. We take the molds of the teeth using second molars, and we fill them with epoxy resin to create a cast of the tooth. We can then use this cast, put it under a microscope, and view it at 50 to 100 magnification. We'll take photos of this using the microscope, and then we analyze the results with a software called Mountains Map, which is 3D height mapping software. It's also worth noting that using clear epoxy resin allowed us to take some different perspectives of the teeth using different lighting and angles, which wouldn't have been possible if we were just using the teeth themselves. So now we've established the methodologies, let's have a quick look at the sample. We initially planned to carry out both forms of analysis on the teeth of 40 individuals. However, 9 were disqualified completely due to unsuitable anatomy, where either the necessary teeth were absent or they were too worn or just didn't have dental calculus present. There were 31 individuals remaining, 24 of which we conducted DMTA on, and 28 of which were used for CMA. 18 of these individuals had pathologies which were visible in their bone or their dentition. And if we break it down into the demographics, we'd initially applied for the individuals to be roughly half male and half female, but we end up having to disqualify more female remains than male due to time constraints as well. We weren't able to rectify this and get an even more even sex distribution. So in the end, the sample was about 40% female with 12 individuals and 60% male with 18. There was also one subject which was not sexable. And in terms of age, there's a pretty large variety with ages ranging from late teens to potentially in their 50s. All of the individuals were adults, with juveniles and older adults being excluded from the sample. This is because younger people may not have had their second molars fully erupted yet, they might not have grown in yet, meaning that we couldn't use them for DMTA, and they may not have had dental calculus buildup, which we would have needed for CMA. Older adults were also excluded because their teeth were much more likely to have excessive wear or antemortem tooth loss, making DMTA impossible. Now, if we look at the age distribution, if broken down by sex, we can see that the female remains are largely slightly older, with most being around their 30s or older. There are 3 younger female individuals between 17 to 30 as well, but they sway a little older than the male individuals who are fairly spread out throughout the age ranges. The age groupings aren't exclusive to one another as well, as the age categories have been taken directly from the age estimates of the remains. So now that we've got all of that done and looked at the methodologies and the sample, let's get into the actual results. CMA results showed a significant presence of charcoal and fabric fibres, with both being present in 22 of the 28 individuals analysed with this method. There was also cooked food in the calculus of 12 individuals, uncooked plant remains in 7, and one had potential starch. We won't be looking at the fungus or phosphate discoloration since they're contaminants from the burial environment and they don't reflect the life patterns, life ways of the individuals. So now on to the DMTA results. ASFC, or area scale fractal complexity, is one of the 4 ways that you can score dental microwear. We could only use one scoring criteria for this project due to time constraints, and we went for ASFC. It's the most telling, in my opinion. It tells us about the roughness and the complexity of a surface. So, for context with the numbers, ASFC scores are pretty variable depending on the population they're being used on. So, what's considered high, medium, and low here is unique to the site and was calculated from this sample. Lower scores are associated with a softer, tougher diet containing foods like cooked vegetables and meat. So these are foods where they would be soft, but they would need to be chewed quite a lot, which would leave shearing patterns on the teeth. Because of the foods they reflect, low scores are also often associated with farming. On the other hand, high scores are associated with diets with a lot of hard, crunchy foods like nuts, and these higher scores, because of that, are associated largely with foraging. Medium scores suggest a mix of both soft, tough farmed foods and crunchy, hard forage foods, and are quite often associated with pastoralism. And as we can see in this table, overall men averaged within the medium bracket, while the average score for women was significantly higher. But it is notable here that only 4 of the individuals who microwear was were analysed were female. This is because many of the female remains had either missing or overly worn molars, so had to be disqualified. So now that we've covered those results, we can get into the discussion and think about what this can tell us about life in early medieval Wales. So we're going to start by looking at spinning and textiles at the site. The vast majority of remains had potential fabric fibres within their dental calculus, 91% of female remains and 56% of male remains. Now, this could be an indicator of woolworking, perhaps. There were spindle whorls discovered at the site, so we know that there was working of fibres on spindles. And we also know that cottage industry was huge at this time, with most communities creating their own textiles rather than trading for them. Now, we're unsure exactly of how easy these fibres are to inhale. There is room for some experimental archaeology there. So it could just be that this is a result of people being near to fabric working or just to the clothes that they were wearing or other textiles they were using. And there is also another much more involved potential. This idea was suggested to me by Rhiannon Camo, who is the membership secretary of Cambrian. So thank you very much again, Rhiannon. This is the idea that the fabric workers in Llandough were using the spit splice, which is a technique of joining 2 yarns that we still use today. With this technique, you unwind the ends of 2 yarns and essentially stick them in your mouth, suck on them, roll them with your tongue, and it joins them together into 1 yarn and fuses them. So this is an old-fashioned method that we still use today, and it does work very well. I asked my mum, who spins her own wool, and it does still work. So we know that is a possibility. We also know from previous work by Anita Radini that using your mouth as a tool during crafting in the medieval period can leave traces in dental calculus. Her study of a medieval woman in Dalheim, Germany, showed presence of lapis lazuli pigment from the licking the nib of her brush while using paint containing lapis lazuli. So this is a real possibility. The presence of these fibres among so many male individuals also, particularly if they're a result of either spindle use or spit splicing, suggests potential for male textile workers in medieval Llandough. Um, Perhaps as a form of monastic craft, we know that there were crafts being carried out at monasteries in Wales at this time. But either way, it's certain that there was significant interaction with textiles among this population. Now, similarly to fabric fibres, charcoal was a very frequent find within the calculus. In fact, um, charcoal was present in 79% of the sample and frequent in both male and female individuals. We already know that cooking was frequent at the site, as we found cooked food within the dental calculus of 43% of the sample. Therefore, it's probable that some of the charcoal is a result of cooking food over a hearth or an open flame. However, it can't be discounted that at least some of this charcoal is perhaps a result of metalworking. Slag was also excavated from the site, suggesting ore smelting. We know that metal tools would have been needed in the community for butchery, mining, farming, among other things. So as a result, it is probable that smithing, or at least some form of metalworking, was being carried out at the site. Trade routes in Wales were not as freely flowing as they would be in future periods. So this community was largely self-sufficient. Um, Therefore, there's a high probability that both cooking and inhaling from fire-based occupations such as smithing could have caused the presence of microcharcoals. There are clear sex-based discrepancies between the male and female diets at the site. Firstly, the diets of the men were richer and softer, with lower ASFC scores on average, as well as cooked food being present in their dental calculus. In contrast, female remains had much higher ASFC scores on average, suggesting a much rougher diet for women. This gender gap could be a result of the site's monastic nature. So, could the richer diets perhaps be a result of a monastic lifestyle? We already know that the monastery traded with merchants in Dinas Powys, buying luxurious goods like wine and oil. And we also know from contemporary accounts that early medieval monks largely ate cooked foods, including vegetables, bread, and fish. I'd also like to point out the bottom image here is a cooked leafy vegetable. And it was suggested to us by Dr. Anita Radini that this could well be a leek, which is a hypothesis that I quite like. Um, it was notably one of the only foods eaten by St. David, and a food that became a symbol of Wales as a whole, but also of early Welsh Christianity. So it is feasible that this discrepancy could be the difference between the diet of monks in the monastery and the women who relied more on foraging without the luxury of a monastic menu. Now, our final point of discussion is the potential of palliative care in early medieval Llandough. This table shows the ASFC scores of the individuals with the most severe osteological pathologies at the site. These are people who would most likely have been considered disabled by these conditions with reduced mobility, and in the case of individual 747, reduced eating capability due to severe periodontal disease. As you can see here, the ASFC scores for those who suffered severe pathologies is on average much lower than the site mean. This suggests that individuals experiencing what we would now call chronic conditions or disabilities were being fed softer diets. This could be as a form of medicine, with ingredients like vegetables and herbs being used to try and improve their conditions. However, there's also potential that this wasn't the case and that the diet was so soft as the individual was not able to feed themselves and was being fed soft and easy to eat foods by somebody else as a form of palliative care. So, in conclusion, the work of this dissertation is revolutionary in the field of diet reconstruction within archaeology. As the first combined use of DMTA and CMA, it's painted a vivid picture of life in medieval Llandough, with a booming cottage industry, homes with vegetables being cooked on, yarn being spun on wool on wheels, and chronically ill individuals being cared for with specialized diets. Archaeological reconstructions such as these are really important as an aspect of archaeology, that we can evoke the past and draw parallels in human behaviors through time. Food's one of the only things that unites people throughout history, and this study opens up exciting new potential for study of changing diet, but also of wider lifeways. So thank you very much. And I've included a sample bibliography here in case anyone's interested. You can give this a screenshot.
Thanks
Okay.
very much.